So hello and welcome again to the last installment of our module on thermodynamics. This time we'll discuss a very cold topic, especially this month of February. So Feb 18 ngayon, nag-record ako. No? Credits pala to the former faculty, Miss Roxanne May Galapo Timbol, since some parts of this presentation was originally from her lectures. No? So I'd like you to pause for a moment, no, and really then pause this video and imagine a life where there are no refrigerators, freezers, or air conditioners. So imagine what kind of world would that be if in this 21st century ay wala tayo ng mga ganitong bagay. Okay, now you have reflected, you probably realize that wala kang malamig na tubig sa Pilipinas. Walang halo-halo dahil walang yelo. Walang tao sa mga malls kasi magpapa-aircon ka lang naman doon. You won't have frozen meats actually, so you have only cured meats in the wet markets. Walang ice cream. And most importantly, most of the COVID-19 vaccines that we have that are not stable at room temperature will not exist. So ganun po ka-importante yung topic na ito. Although you might have discussed this as part of the food processing, I doubt that you have discussed this from the technical perspective of how the vapor compression cycle works. So we'll be using something similar to steam tables for refrigerants in this case. So if you recall the laws of thermodynamics that we discussed, no, nakalagay dun sa second law na hindi ka pwedeng mag-totally transfer ng 100% of the heat from a gradient ng lower temperature to higher temperature. But it means it's possible, and that's what refrigeration does. It reverses the heat transfer direction from mas malamig to mas mainit para lalong mapalamig yung iyong mga stuff to lower than room temp. So the use of mechanical room refrigeration is the key to transferring heat from the system to the surroundings at a temperature lower than the ambient or surrounding temperature. So nung unang panahon, dahil dati pa naman meron ng yelo sa mundo pero limited lang sila either pag winter or kung nasa mga Arctic regions ka or very 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 high elevation places, no? So ice houses were built, say in Iran and Italy, so that you can store ice that you've hauled from somewhere else. And dahil insulated ito mga to, the ice will not melt easily and can be stored for days. And for most of you who'd remember this movie, so meron pa actually mga depiction ang pag-harvest ng ice sa mga pambatang sine, no? So, as early as 1000 BC, the Chinese cut and stored ice, and then the Egyptians, because of the difference of day and night doon na yung Arabian Nights na tinatawag, no? So, Egyptians can make ice kapag sobrang lamig ng gabi, they only need to store water on the pots, and then when they wake up, may yelo na sila. So, then also in the 1800s, natural ice was traded in England, hence the picture below. So before the advent of the vapor compression refrigeration cycle, yun nga, lahat naman na nangyayari is kukuha lang sila ng pre-existent na yelo and i-delay nila yung pagtunaw nito. So the precursor to the refrigerator were ice boxes which could basically serve as refrigerators until the ice melted and they had to get new ones. Of course, this was likely a luxury because the maintenance cost would be expensive. Dahil bibili ka ng yelo na nanggagaling sa kung saan mang malamig na lugar. So that was until people started studying the evaporation of liquids led by William Cullen in the 1700s. So evaporation of liquids in vacuum is the precursor to your refrigerants and how heat transfer, could happen through endothermic reactions na pag nag-vaporize ang isang bagay ay nag-absorb siya ng heat in the process. In the 1800s, Faraday liquefies ammonia to cause cooling. So this would be a precursor to, we know that ammonia right now is very important in refrigerant in the industry, and recently na-implicate pa siya sa news, no, nung nakita natin na merong isang relative ng isang Metro Manila mayor na sa kanyang jurisdiction sa kanyang city ay sumabog yung ammonia pipeline dun sa planta, causing damage to the walls and toxic fumes to leak to the nearby surrounding residential areas. And then finally in 1834, they had attempted the first working vapor compression refrigerator, and the basic technology has been in place and is in use until the 21st century. So kahit may mga kung ano-anong technological improvements, yung pinaka-konsepto ng vapor compression refrigeration, yun at yun pa rin yung ginagamit natin today. Okay, so one key thing with refrigerators is that you should have a refrigerant. This is the liquid that causes the heat transfer from the food to the outside environment, and it is their properties as fluids and gases that allow the refrigeration to take place. So kung tubig yung nilagay mo doon sa loob ng ref, hindi yan gagana sa planet Earth bilang isang refrigerant. Okay? So if you can look at this, unfortunately this one is in Fahrenheit. They usually have very low boiling points, no? They boil at lower than ambient temperature, and therefore at normal temperatures and pressures they exist as gases. Okay? And they also, since heat transfer ang primary goal nila, they also need to have a good heat of vaporization, because the heat of vaporization would determine how much refrigerant you would need. Kapag mas mataas ang heat of vaporization, mas konting refrigerant ang kailangan mo. And that is why for this table, ammonia is the clear winner, because it can absorb the most heat with the same amount of mass of the refrigerant. No, so typically, yung mga refrigerant sa mga household refrigerators natin, hindi pa aabot ng 1 litro yan, no? Kaya yung mga pipes natin sobrang ninipis, parang mga straw lang sa nipis yung mga pipes sa ref natin. Okay, so before we discuss how refrigeration works, we look at the ideal set of qualities, no, that a refrigerant should have. Kumbaga kung may pageant para sa refrigerants, ito yung hinahanap kong criteria for scoring. So first is to have a high latent heat of vaporization. So as sabi ko kanina, this would allow the refrigerant to transfer more heat in one go. Next is low condensing pressure. We'll discuss this later. And then freezing temperature below the evaporator temperature. You also need this to para hindi mag-solidify yung iyong refrigerant. Ideally non-toxic, as we can see yung sa ammonia, yung isang downside niya, but we still use it under regulated conditions. Self-explanatory naman ang non-flammable and non-corrosive and chemically stable. The detection of leaks should be easy because with ammonia, at least alam mo na nagli-leak na kasi sumasakit na yung mata mo. But what is if it was a gas like LPG tapos unscented siya, no? Nasinghot-singhot mo na siya, hindi mo alam. Tapos kung flammable pa yon, nagsindi ka ng lighter, putok kayong lahat. And then of course, you need to have a low cost and low environmental impact. As you can see, that is usually the problem with ammonia, yung pag nag-leak siya, evacuate. So I worked in an ice cream plant, so first hand alam ko ito, no? Nung bago yung aming planta, pag nagkakaroon ng leak ng ammonia, kasi nga it's a gas, no? Magka-pinhole crack ka lang and it's high pressure, lalabas na yon. Talagang mapanghi yung amoy, masakit sa mata. We'd have to run palabas ng planta ng nakapikit, no? Kasi ang hapdi-hapdi niya. Right? And lalo na kung enclosed yung space na iipon yung concentration. Right, so like yan, yung ammonia nga, sabi natin, maganda siya in terms of mataas na heat of vaporization, therefore you need to use much less volume of it or mass. Especially good for larger operations, but it's never used sa mga home style refrigerations for safety concerns. non-corrosive but very, very irritating as I mentioned earlier, toxic at lower concentrations. But the good thing is, kung mag-leak man siya, may mga paraan para ma-detect siya. Minsan ilong lang sapat na. So as we mentioned, not all refrigerants are created equal, and that ammonia has advantages and disadvantages, and mainly used in industrial settings. Chlorofluorocarbons like R12 have been phased out 1994, di pa kayo pinapanganak. R22, less damaging ito sa kalikasan, pero sa US, pini-phase out na rin siya. Typically, yung pinaka-common na ginagamit ngayon for both household and car refrigeration is R134A. I've been mentioning the vapor compression cycle for a while now, and if you have your household refrigerator, actually what happens inside is the refrigerant flows through and changes phase, liquid to gas or gas to liquid in the process, and as it transfers heat. So actually yung mainit na part sa likod ng ref nyo, that's around 40 degrees. Ayun yung condenser. Okay. And of course your compressor, it's that big thing underneath. The evaporator is where the food cooling takes place. No? So it absorbs heat from the food as the gas vaporizes, because you need energy to vaporize your gas. Okay, and then the expansion valve is the what connects the evaporator to the condenser and mostly regulates the flow of the refrigerant. So ngayon naintindihan niyo na yung analogy ng bike pump and spray can. We can now look at the vapor compression cycle in depth, step by step. We can start anywhere, but let's start dito sa expansion. So the refrigerant in this case is in a saturated liquid state, meaning to say pwede na siyang mag-evaporate anytime. Okay? And as it evaporates, no, merong kang pressure drop dahil, as it expands rather. So from a high pressure state to a low pressure state, nagkakaroon ka ng pressure drop and what we call the flash gas na partial evaporation. So nagiging vapor liquid mixture muna siya, of course. Okay, and then it enters the evaporator at this location. When we go to the evaporator, from vapor liquid state ay nagiging saturated vapor siya, thereby absorbing in the process yung lahat ng heat sa kanyang surroundings, which is yung food. Okay? And in certain cases, the saturated vapors may be even superheated sa dami ng heat na na-absorb niya. So itong evaporator, yan yung coils na nasa ilalim ng patungan ng freezer ninyo or nakapalibot dun sa bod sa interior ng refrigerator. Okay. So once the saturated or superheated vapor enters the compressor, okay, we at location A, then nangyayari dito ay itong hot gases na ito ay i-compress palalo. So dyan manggagaling yung input galing sa kuryente, yung motor ng compressor. Itong hot gases ay lalo pa niyang i-increase yung enthalpy by compressing the gases with the energy from your electricity. Okay, this would lead to an increase in temperature, which would often be would lead to it being superheated. Okay, and then when we forward this to the condenser, so yung compressed hot gas na yon ay ipapakam into contact mo with a relatively cooler surface, which is yung heat exchange to the ambient environment. Okay, and dun mangyayari yung, kaya umiinit yung likod ng ref ninyo. Kasi yung compressed refrigerant, hot refrigerant, ay magi-give off ng heat. Okay? And it's possible actually for the temperature to decrease below the condensation temperature. So, pwedeng saturated or subcooled yung liquid by the time it enters the expansion valve to continue the cycle. So this is just another illustration now showing the physical components. The compressor is where most of the refrigerator's power consumption goes now when it runs to compress your gas. So therefore you now have a hot gas. And then in the condenser, we use cooling fans to sap heat away from the condenser to the environment para nag-start na siyang lumamig. Okay? And then as it does so, nagiging liquid uli yung refrigerant. And then when you expand it, it becomes a vapor liquid mixture. And then as it passes through the evaporator, again yung air, ito yung galing sa food mo na hangin na nagsa-circulate. So yung heat galing sa food nanggagaling dito, hini-heat up niya yung refrigerant in the evaporator. So in the process, lumalamig yung hangin and itong malamig na hangin na ito yung nagpapalamig sa pagkain mo. Okay? And then this hotter evaporated gas is what goes into the compressor. Alright, so we now have this standard vapor compression cycle chart which demonstrates kung ano yung nagiging changes in pressure, enthalpy, temperature, and the state of your fluid as it undergoes each step in the process. So for the evaporator, what happens is that the liquid refrigerant vaporizes into a gaseous state. So kaya nga evaporator. And of course, this would require latent heat extracted from the surroundings. So ito yung phase na nagkakos ng paglamig or pag-heat transfer from yung reverse direction na hot to cold. No? So as the compressed gas is deep pressure, so in here you have equal pressure from the previous stage, an increase in enthalpy. As it evaporates, pwedeng hindi magbago yung temperature niya, pero kung maging superheated vapor siya, so magi-increase yon. And since it's evaporating, the final state after this would now be a gas. So as the gas now goes through the next stage, which is the compressor, again, ang role ng compressor is to pressurize the gas and increase the temperature in the process. Okay. So in the pressure enthalpy diagram, that corresponds to both an increase in pressure and enthalpy, as well as temperature. And in this case, even though you are compressing it, it remains gas. Kasi habang kino-compress mo siya, ini-increase mo yung temperature niya. So yung proportional na increase ng pressure at temperature prevents it from condensing into liquid. We will not be discussing the three different types of compressors nor how they work, but we'll just mention them here that there's more than one type of compressor. No? So we have the reciprocating, the centrifugal, and the rotary. But generally, these work by having something like pistons compressing a certain volume of in chamber mo. No? So maybe a bit similar to what you see in internal combustion engines. And then usually this is operated using an electric motor, but in certain cases you may have petroleum powered refrigerators. So the only difference actually sa kanila is ano yung pinapower ng compressor, but essentially the same yung vapor compression cycle nila. So again, the condenser is where the system unloads the heat obtained from your food into the surrounding environment outside your refrigerator. Okay, so this is done through the use of air or water cooling. Okay, and the refrigerant condenses back to a liquid from its gaseous state in the process. So remember when you're lowering the enthalpy and the temperature as well. So kung saturated vapor man ito, equal pressure pa rin siya until maging saturated liquid siya. Okay, and usually to facilitate the cooling, you would have a high surface area. So you have either the tube and fin type or plate type condensers. You can Google for pictures, but I guess yung mga fin type, alam niyo na naman yan, yung mga nakikita niyo sa likod ng mga traditional window type aircon. But the gist here is to have a very high surface area for heat transfer. Okay, so yung expansion valve naman, as it is defined, no, is a metering device controlling the refrigerant flow from one side to the evaporator. So galing sa condenser, siya yung bahalang mag-dispense, quote-unquote, ng liquid. Depende sa flow rate na kailangan for refrigeration. Okay, so as the gas expands, meaning you are depressurizing it, nag-start na siya mag-cool prior to evaporation. However, in this case, the enthalpy remains the same despite there being a decrease in temperature. And in this case, you have a vapor-liquid mixture. Kaya question mark yung pressure kasi nga nag-expand ka so hindi uniform yung pressure niya on either side. So there are many different types of expansion valves, but that will not be the part of our coverage since we are focused on understanding the vapor compression cycle.